All right, let's get right into it. We're diving deep into what might be the most important race on the planet right now. A competition that's not just about technology, but about who literally holds the keys to the future. We are talking about the global quantum race. This quote right here, it just hits the nail on the head. We're way past talking about qubits as just, the building blocks for quantum computers. This is about a fundamental tectonic shift in global power and security. It's not about making faster machines. It's about who gets to write the script for the next 100 years.
For decades, quantum computing felt like something straight out of science fiction. But that's all changed. We've officially hit what you could call a tipping point. This tech has moved out of the theoretical lab and straight onto the world stage, and it's now a very real, very serious factor in geopolitics today.
So, why this mad dash all of a sudden? Well, because the starting gun has already fired. Some countries are on an all-out sprint, others are playing it cool, pacing themselves strategically. And yeah, a few are still kind of standing on the sidelines, trying to figure out if they should even get in the race. Honestly, the best way to think about this is as the new space race. But instead of shooting for the moon, the real target is the invisible, mind-bending world of quantum mechanics. We're seeing nations throwing billions of dollars at this, building completely new kinds of infrastructure, these quantum highways, and they are locking in their game plans for the next decade. This sense of urgency is just palpable.
So let's talk about the frontrunners. Who's leading the pack? These are the nations making absolutely massive bets. But here's the fascinating part. They are not all playing the same game. Their strategies for how to win are dramatically different.
Okay, so this chart really brings those different strategies to life. Just look at China, an all-in sprint. That fits perfectly with its goal of total quantum supremacy. Then you contrast that with the US, which is playing more of a measured chess game, really focused on security and building up its talent pool. And then you've got these other fascinating plays, like Australia's Moonshot, a huge, high-risk, high-reward bet, and Canada's scalpel approach, just surgically targeting very specific commercial areas. Each racing style is custom-built for a totally unique national goal.
Now, let's zoom in on the two biggest players, because their approaches couldn't be more different. China's strategy is state-driven, it's top-down, and it's massive. They are literally building entire cities dedicated to quantum research. The goal? Total supremacy. No ambiguity there. The US is on a different path, sort of a public-private poker game, leveraging the speed and agility of its private sector. The goal there isn't just about speed, it's about strategic, long-term control, especially when it comes to security.
Now, you might look at this number and think it's not the biggest on the board. But that would be missing the point. The UK's £500 million investment isn't about trying to outspend everyone. No, this is a targeted strike. It's aimed at absolutely critical fields like quantum-safe encryption. It's what you call the quiet inventor approach. Incredibly focused, strategic, and precise.
And of course, the field of frontrunners is much broader. You see this differentiation everywhere. France is zeroing in on that really practical and difficult step of getting technology out of the lab and into the marketplace. India is busy building these powerful regional hubs specifically for cryptography. And Japan? Japan is playing to its historic strengths, precision engineering, superconductors, and forging these super tight links between its universities and its industries.
But it's not all about the big spenders, is it? There is a whole other tier of nations in this race. And being in this chasing pack doesn't mean you're losing. It just means you're playing a different game. And some of these players are making some incredibly clever moves.
These are the climbers, and their ambition is super clear. They're not necessarily trying to lead the entire race, but they are absolutely determined to have a real stake in the quantum future. You see Brazil making this incredibly bold pivot with a billion-dollar plan. You see Austria just methodically laying the bricks, building its foundations. But what I find most fascinating is the entry of a player like South Africa. It just shows that this race is expanding way beyond the usual tech superpowers.
And then you have the sleepers. These are the countries that are kind of watching from the sidelines. And while a small investment, like what you see in a place like Argentina, is a start, it's not a full-blown national strategy yet. And the risk they face is just huge. If they wait too long, they could fall so far behind that their only option will be to license all of this powerful technology from the winners. That creates a future of deep, deep technological dependence. Okay, so with all this talk of a race, what does the finish line even look like? Let's shift our focus a bit. Let's talk about what winning is actually going to mean over the next very critical decade, because the prize here is so much bigger than just a faster computer.
This quote just nails the paradigm shift. The tech revolution of the 20th century, the internet, that was about controlling information. This revolution is about mastering uncertainty, which is the weird, spooky principle at the very heart of quantum mechanics. It's a completely new kind of power, and it's going to be fought with physics and with code.
So how's this all going to play out? Well, right now, in 2025, we're in the opening phase. Nations are locking in their strategies. But by the end of the decade, you're going to see a hard pivot from pure research to actual commercial products. And then by 2035, wow, the winners won't just have a new toy. They will have fundamentally redefined the global power map, gaining enormous leverage over security, economics, and defense. So when you boil it all down, we're really looking at two very different futures taking shape. On one side, you have the winners. They're the ones who master the really hard stuff, like entanglement and error correction. They will build leverage, they'll control the digital keys to this new world, and they will literally get to rewrite the rules of the economy. And on the other side, you have the dependents, the ones who waited too long. They'll be forced to license that power from everyone else.
Which brings us to the ultimate takeaway here. In this race, the cost of waiting, the price of hesitating, it's not going to be measured in dollars or pounds. It's going to be measured in sovereignty, in security, in economic freedom. In the quantum era, doing nothing, that might be the most expensive decision a nation could possibly make.
And so we end right back where we started, with the central question of our time. As this technology moves from a theoretical concept into a world-changing reality, the race is on. Not just to build it, but to define it. The question for the next decade is simple, but it is so profound. Who is going to write the rules?